So what we're doing here is we are setting the 0, 0 mark. And in this case we want to set 0, 0 to this corner here on this board. We're using a router operation. So the first thing we need to do is move the tool below the surface of the part. And we can do that by Z downwards. And we're continuous jog at a fairly fast, fairly fast speed. Now if you look, we are below the edge of the part. So now we can basically we want to move the tool near the part. I'm slowing down jog speed, safety glasses, and we get close. Now we can go to jog step. So to go to jog step, it's basically F8. And now it moves at a step in time rather than a continuous motion. So basically what we can do is use our piece of paper. I guess we have a ways to go. Move closer. We want to make sure that the tool is against the edge, the flute of the tool. Now we're stuck. Now we're close enough, so now we can change our jog step to 1/1000th of an inch. Sliding the paper back and forth. Now the paper is caught. Now this is 3/1000ths of an inch is about a piece of paper, so 1, 2, 3 steps in the Y direction. And now we can come here and we want to 0, and we're moving in the Y direction. So we now 0 our Y direction, and you can see here that we are at X0, Y0, and Z at minus 0.25. Now we want to basically back our way out, and we can go to continuous jog and basically back out, and then we want to scoot over, and in here so we've set the Y direction, so the next step is the X direction. So we want to feed over, and we can use the arrow keys to feed. Adjust the tool so that the edge is going the right way, and then we're moving our way back, and you can see that we're beyond the edge of the part. And then we want to get basically close. Now that we're close, we can set it up. Is this super zoom? Is this proceed or not? So basically want to do what we did before and step in. So change this to F8. And you can hold it down. And I'm stepping in. Stepping in. Stepping in. It's a little further than I thought. Still can move. Stepping in. Alright, now it's stuck. We can back away. Now we can barely move, so 1/1000th at a time. So now we're stuck. 1, 2, 3/1000ths to set that. Now we can go over to this machine over here. And now we want to 0. And we were moving in the X direction, so we want to 0 our X. So now if we look up here, X is equal to 0 and Y is equal to 5.5 7, which matches what we think. And then we want to basically back away and then lift up our z-axis so that we're above our part. Now if you look at our thing, basically what we said is this edge equal to 0 and then the front edge also equal to 0. But what we want to do is set the center of the tool to 0, 0. And so to do that we need to go to 0.5, 0.5. So over here we can hit go to X of, it's a 1/2 inch tool, so it's 0.25. Oops, and a Y of 0.25. And now, if we hit go, now if things worked out right, basically we have the center of the tool directly over our edge of the workpiece. And over here you can see it's also directly over the center of the workpiece. So now we've set 0, 0 for the tool. So now we need to 0, we want to 0 the X and 0 the Y. So now this is 0, 0 at the left hand corner of the part. Next thing we want to do is actually set the tool length offset. So we basically need to figure out where the end of the tool is compared to the top of the part. And we'll need to lift up a little higher than what we got. So lifting up the Z. Now there's a special device, and as long as you're using a metal tool, basically what's going to happen is when the top of the tool comes in contact with this plate, it knows the thickness of this plate, so it can automatically set the tool length offset basically like that. So looking over here, that would be under the tool, and then touch off Z0 position, and it touches off. Let's do it again. Watch it. So tool, touch off tool 0, goes down, touches, there we go. Now this isn't the tool we actually wanted. We're just doing a router demonstration this time because I want to see how well it works. It should be a cool CPU shield. So to remove the tool, we have basically tool, 2 different wrenches, 2 different bolts right here, and righty tighty, lefty loosey. So I gotta push the other way, and it's basically set up so that you can squeeze them together in the counter moment. So basically, unscrew. This is a collet. It allows you to basically slip the tool in. So the collet basically clamps around the tool when the nut is tightened. It slips out. Slip your new tool in. Got to face it the right way. This is a router bit. Nice sharp point. Makes pretty engravings. So as this clamps in, this is going to clamp around the tool, and we can go ahead and get it tight, and then the 2 wrenches by each other and get it quite tight. So now the tool is firmly in there. We've got a new tool. We need to also figure out the tool length offset for this one. So just like before, put it in there. Tool, touch off Z0. And since this tool is higher, it doesn't take it down. So basically now the tool knows where Z is equal to 0. Z is equal to 0 is defined at the top of the part. Now that we're done with this, Put it back up in the rack up top so we don't mess it up. And then I like to go to 0, 0 on the X and Y. So when you turn off the machine, whenever it's done with the program, it always goes back to where you scripted it at. So now we go to 0, 0. So that way we don't have to learn the new origin for our part. Okay, next thing we want to do is actually load our part. And so we can file. Okay, so I've emailed myself the code that I made in Mastercam, and basically you have to save it in the right directory. Going into here, it's C:\mastercam mil and C is where it automatically saves the code for this one. So coming over here, C:\mastercam X3 mil and C, and then CBU shield 2. So now this didn't update it, so let's see. Shield 2 and C. Okay. Now we basically want to preview it. And so this is basically what we have. You can zoom out. Want to make sure it looks like what we think it's going to do. So here's 0, 0. It's cutting on the wrong side of the part, the right side of the part. We're going to engrave this, we're going to engrave this, and these are the paths we're going to do. So it looks good. Now we're basically almost ready to run. So basically we need to shut the doors, make sure the emergency stop is off. It's sort of ironic that the emergency stop is behind closed doors. But basically you want to shut the door. And let's see what the speed this is set at. So the speed of the router is set up here. It's set at the low speed. It's set at a medium speed. And this is the first time I've used a router setting. And so basically we're going to run. Hit start. Oh, you must pre-process it, so we'll pre-process it. Now pre-processing complete. 22 minutes to run it. Now when we hit start, spinning, and I'm going to make the feed rate override down at 50% because I haven't actually tried machining at this setting. This was the default feeds and speeds for the router. Hit resume. It's basically going over. Bringing its way in. And it looks like the zero offset is not right. Okay, we're going to try this again. Basically we had the board is really warped. So we touched off in the middle. You see it's still warped. We're engraving all the way around. seem to be going fine on the feed rate. About 100% speed. Oh, let it run. So this is a finished product. This is what we get. You can see that in this end we didn't cut as deeply. This end is deeper just because of what is warped going up.